This problem we're going to explain is limit. But before I start making my problem, I want to explain what a concept of a limit is. What is a limit? Is the mathematical concept based on the idea of closeness, used primarily to assign values to certain functions at points where no values are defined in such a way as to be consistent with nearby values. So now that we know what a limit is, I can start with my procedure. The problem given is limit at x extends to 5 from the right side of the square root of x negative 5. So we need to plot in the 5 where the x is, in this case inside the square root. Then add or subtract, here subtract 5 minus 5, which is 0, and then calculate the square root of 0, which is 0. That will be your answer, since limit of 5 approaching from the right side is 0. This problem was easy since 5 positive when plugged in gave us 0, but normally when we have a positive or negative besides a number, and when plugged in gives DNE or 0 over 0, we need to make a whole different procedure, but this is not the case. This can be seen on a graph. It shows that the limit as x extends to 5 from the right side is 0.
In problem 54, we will use derivatives. But first, what is a derivative? A derivative is the rate of change of a function, f of x, at a given point. Now, there are two ways of finding the derivative of a function. The first one is by definition, by a formula. The derivative of a function is equal to the limit as h tends to 0 of f of x plus h minus f of x divided by h. And the second one is using the power rule, which is another formula. The derivative of f of x equals to n times x and the power minus 1.
Okay, so first we're gonna solve the problem f of x equals 2x to the third power minus x to the second power plus 5x plus 7. So as we are gonna find the derivative of this problem by definition, we have to plug in x plus h in all of the x's of our problem. So we are gonna put 2 parentheses x plus h to the third power minus x plus h to the second power plus 5 in parentheses x plus h plus 7. Then we're gonna expand these parentheses. For example, in x plus h to the third power, we're gonna put x to the third power plus 3x to the second power h plus 3xh to the second power plus h to the third power, parentheses minus, and then you expand the next parentheses plus 5 and you multiply just 5 plus x plus h. Then the next step is to, well, you multiply whatever is on the parentheses by what you have on the outside, which is gonna result this product.
The next step is to locate f of x plus h in the formula given above. The next step is to substitute the new function with the other function in the formula. First, you plug in all of the product that came in from substituting x with x plus h, and then subtracting it minus the initial function, 2x to the third power minus x to the second power plus x plus 7. All of that over h. Then, you're gonna multiply the negative sign without the function and cancel the common numbers. After doing that, you will have only the simplified version of your first function. After that, we need to eliminate common products. We need to eliminate the h underneath that it's dividing the whole equation. So we take out an h from our nominator. After that, we cancel the h, and the rest of the h's we just substituted with 0, since the formula says that the limit is as h tends to 0. After that, we just simplify and we get the end result, which is 6x to the second power minus 2x plus 5. To verify if a problem was done right, we can always use the power rule with the formula nx to the n power minus 1. To do this, you need to take each number into account. In this case, you will first take the number 2x to the cubic power. you will take the 3, which is the exponent, and multiply it times its coefficient, which is 2. So it'll be 2 times 3 and then x to the power, which is 3 minus 1. And you will do this for all the rest of the equation. Be careful with single numbers, such as number 7. Since it doesn't have an x, then the derivative will be a 0. Now multiply and subtract to get the final product, the final derivative, which is the same one that we did before. This means that we did the differentiation process correctly.